This video will demonstrate how to set up the DataQuest configuration. From your desktop, you can select the ultra-wide icon to open the ultra-wide. From the DataQuest drop-down menu, select Config. A file selection window will appear that will show all the files present on your DataQuest SD card. The config.bin file is the system's configuration file that holds the setup of the entire system. Before making any changes, I would suggest making a backup copy of this file. You can copy it to your hard disk and/or make a backup copy on the SD card itself by copying, pasting, and renaming. Now, by simply double-clicking on the config file, we can load the configuration.
One available feature in the configuration is the pop-up help. This feature can be turned on or off, and when turned on, will enable a description or instruction message to pop up whenever the mouse is positioned over a parameter in the configuration window. This feature is useful while getting used to working in the configuration program. Because we will be explaining these parameters during this video, I'm going to turn the pop-up help off for now.
Before getting into the configuration further, I would like to explain that the configuration file will have been set up prior to shipping the DataQuest system per your original order. Therefore, there will be no need to configure your system unless you want to make changes. Alternates will also have a copy of your configuration on record so that in case something does get changed in the configuration, we can email you your original config. Alternates can also update your config for you and simply email it to you with any changes you wish. But hopefully after watching this video, you will feel comfortable making the changes yourself. The configuration screen has several sections, each color-coded. These sections include channel, touchscreen, record, and shift point setup. We'll first go through the channel setup. At the top, we can select any channel by clicking on the channel selector.
The first 11 channels, channels 0 through 10, are controlled by the main control unit or MCU, and therefore are always present and can be enabled in the system. These channels include engine, drive shaft, clutch RPM, 3-axis of acceleration, battery voltage, and 4 general purpose analog inputs. The next 32 channels are controlled by the CAN bus. The engine and drive shaft RPM, channels 0 and 1, are always enabled. Channel 2 is for clutch or converter RPM. This channel should only be enabled if an RPM sensor is physically installed on the input shaft of the transmission. Leaving it disabled and not installing a sensor still allows the DataQuest system to determine clutch or converter RPM and slip. This is accomplished by analyzing engine and drive shaft RPM along with the transmission gear ratios, which we will configure later in this video. Although this sensorless method cannot distinguish between any slippage in the transmission itself and the clutch or converter, it is still an accurate number for the total slippage in the drivetrain.
Below that is a gray box that shows the channel specifications. These include which bus the channel connects to, the sample rate, and if it is a CAN network channel, it will show which node the port is on. So let's say we want to add a fuel pressure sensor to the CAN network of our system. We first want to scroll through our available channels and find an open port on one of our nodes. So if we scroll to channel 14, we see that currently port 4 on node 1 is disabled. We can go ahead and enable the channel. Since the fuel pressure, we can label it appropriately. If you were to have several fuel pressure sensors in the system, you might want to designate them as such, 1, 2, 3, or 4. We're going to put PSI in for the units, for pounds per square inch. And this is going to be a standard sensor, so we can scroll up here to the standard sensors and click 15 PSI sensor. So now that sensor is enabled in the system. We can further go down here and set warnings up for this. This can be done on any channel in the system. We can set a high or low warning, and we can output it in multiple outputs or to the screen. So for our fuel pressure, let's say we want to have a warning limit at 5 pounds, and we want that to trip if it goes below 5 pounds, so we set it to low. Now we can output this warning on any of our 4 warning outputs. You can do it on all 4 or any one that you want. And basically once the warning occurs, it's going to set this output number 1, which we've selected, to 12 volts. We can also enable the warning output to our screen if we have our touchscreen dash in the system. This will bring up a red LED indication on the screen along with the appropriate channel name, in this case fuel pressure. The last selectable field in our channel setup is our filter level. Our filter level allows us to set a default filtering for our channel. In the case of fuel pressure, if it's a carbureted application and you have the sensor close to your needle and seat, you may tend to see a lot of fluctuation due to the needle and seat opening and closing. So what you may want to do is set your filter level up to about, let's say, 5. And what this does is every time you go into the graphing software and select this channel, it automatically will filter to a level of 5. The graphing software does also allow you to change this level on the fly if you want to adjust it a little higher or a little lower. But basically this just allows it to be a simpler graphing where you're not constantly readjusting all these channels every time you graph them.
The DataQuest also allows for configuring a custom sensor that may have an uncommon voltage output. In this example, we will configure an infrared temperature sensor to measure tire temperature, which has a 0 to 3 volt output. If we want to install this sensor on the network, we must first find an open port on an installed analog node box. Scrolling through, we see channel 15 or node 2 port 1 is available. We make the channel active by enabling it. Now enter an appropriate label such as tire temperature RR for right rear tire. Enter a unit of F for Fahrenheit. Under the analog sensor type, we can select custom since the sensor's voltage levels do not meet any of the standard selections. Additional parameters for the custom sensor will appear, and we can enter the min and max voltage of 0 and 3 volts and the min and max value of 0 and 300 degrees Fahrenheit. Now we can set a warning limit of 150 degrees, enable an output channel for that warning, and set a filter level for this channel. Now we can save the configuration to the CFG file on the memory card, and the sensor will be configured. All the necessary information required to configure the sensor can be found on the spec sheet that accompanies the sensor when purchased. Next, we can move to the touchscreen display or TSD configuration. The TSD configuration is applicable only if you have the TSD installed in your system. This section allows for configuring which 40 channels you want to enable into the 4 field areas on each of the 10 selectable screens.
Each screen has 4 fields that can be set to show any channel in the system. The 4 fields I'm referring to are shown here on the display. Pressing the screen selection button will allow you to change between the 10 different screens. Each field will display the selected channel. Each field is independent on each screen, so if you desire, you can select the same channel in each field or have the same channel appear on multiple screens. To set a channel to a field, simply click on the field to open a drop-down list of channels, then click on the channel. In this example, we're setting channel 11, air-fuel ratio, to both fields 1 and 2 of screen 1 and field 1 of screen 2. After making changes to the field setup, make sure to press the Save Touch Display Setup button. Then save your configuration to memory card. Now we can configure how DataQuest will start and stop recording. Recording can be activated by RPM or manual activation. If RPM is selected, you must enter an RPM value to activate. As an example, if you set the RPM to 5,000, DataQuest will begin recording as soon as the engine reaches 5,000 RPM. If you select to manually activate, recording will start if the record button is pressed on the touchscreen display or if the remote switch connected to the MCU is pressed. Recording can be stopped by RPM, time, or manual button press. Again, if RPM is selected, a stop RPM value must be entered. While recording, if the engine drops below the stop value, DataQuest will stop recording. The stop RPM will typically be lower than the start RPM value. If time is selected, then DataQuest will record until the set amount of time after activation. Recording can also be stopped manually by pressing the record button on the touchscreen display. The last configurable parameter is the shift point section. This section allows you to enter the gear ratios of your transmission and the shift RPM for each shift. First, enter the number of transmission gears, then enter the gear ratio for each shift. Next, enter the shift RPM for each shift. If you want to output a 12-volt signal at each shift, you can select which of the 4 outputs to set. If you want to display a shift light on the touchscreen display, then enable the shift output to screen. This concludes how to configure the DataQuest.